Whoa, there's a lot of stuff on the board on this one. Well, because we're starting to enter in how to graph some complex functions. And the first function that we're looking at that's fairly complex is a quadratic. So we looked earlier at the standard form of a quadratic that we discovered was g of x, or whatever name we want to call it, equals a x minus h squared plus k. And those components that we had were based on the transformations that we learned a while back. This was my vertical shift, this was my horizontal shift, and this is my up or down factor that we had in the particular quadratic. So if I remember some of those components and applied them, I can look at our standard form and begin to graph them. So over on the right side, I have 5 ideas or 5 steps to help us graph a particular quadratic. The first thing that we want to look at is, does the graph open upwards or does it open downwards? And to determine that, I look at the coefficient of a, which in this function is represented by a negative 2, but a negative. And a negative tells me that the graph opens downward. The second point I wanted to determine is, where's the vertex of this function? And if you remember, and some of you guys are filing through and looking right now, you remember the vertex of this particular function is located at the point h and k. Again, that was my horizontal shift and my vertical shift, h and k. So h is designated as a 3 and the k is an 8. So my vertex is at the point 3 and 8. So I'm starting to get an idea where this graph exists at. The next thing I want to look at is determine if there's any x-intercepts involved. And we look at x-intercepts by evaluating the function or solving or setting the function equal to 0 and solving. So let's take the function f of x, set it equal to 0. Subtract 8 from both sides. Let's divide both sides by -2. Let's take the square root of both sides. So that gives me x minus 3 equals a positive square root of 4, or x minus 3 equals a negative square root of 4. So x minus 3 equals a 2. X minus 3 equals a -2. X equals 5, or x equals 1. So I determined that I have x-intercepts. I have 2 of them, and I have them on the x-axis at the point 1 and at the point 5. So let's go ahead and say my x-intercepts are at the point 5, or 1 and 0 and 5 and 0. I could have also used a quadratic formula. I could have also squared both sides, solve by squaring. However you wanted to do it, you can solve your quadratic however you want to. Step number 4, I want to determine if this graph has any y-intercepts. And in this case, that's evaluating the function at f of 0. So let's look at that. F of 0. One step at a time. -3 squared gives me a 9. Minus 18 plus an 8 equals a 10. And so f of 0 equals 10. And that tells me that I have a y-intercept at the point, at -10. At -10 and 0. So if I take all that information that I have, I can begin to plot a great graph. So let's draw some x-axis. I have a vertex at the point 3 and 8. So over 3, up 8, 1, 2, 3, 4, 5, 6, 7, 8. I have a vertex roughly there. I know that the graph opens downward, so I can start to kind of make a downward looking shape. I know that it crosses the x-axis at the point 1 and 0 and 5 and 0. Right there, so I know that it comes down this way and it comes down that way. I also determined that its y-intercept, where it crosses the y-axis, is at -10. So it crosses right there, so I can continue that graph roughly through that point. I know that this graph is symmetric, so it also has the same field that direction. And then lastly, I can plot some more points if I need to determine better where that graph looks like. But generally, if I know where that vertex is at, its x-axis points, or its x-intercepts and its y-intercepts, I have enough information to draw a really good graph. And it's kind of cool.